Acceptance tests for pre-purchased oil-filled PADMANT transformers are crucial to verifying the equipment's condition upon arrival. The tests outlined here cover essential aspects of the transformer's integrity and performance. Firstly, perform a visual inspection. This involves a thorough examination of the transformer for any physical damage, such as scratches, dents, or deformities. Pay close attention to the nameplate data, ensuring it matches the specified requirements on purchase order. Carefully inspect the bushings, terminal connections, and gaskets, looking for any signs of defects, cracks, or leaks. Secondly, conduct a transformer turns ratio test, often abbreviated as TTR. This test measures the ratio of the transformer's primary voltage to its secondary voltage. The TTR test serves to verify the transformer's winding connections and the overall turns ratio accuracy, ensuring it aligns with the design specifications. Thirdly, perform a power factor test, also known as a dissipation factor test. This test assesses the insulation loss within the transformer. It provides insights into the quality of the winding insulation and can indicate the presence of moisture or other contaminants. A high power factor reading suggests potential insulation degradation. Fourthly, conduct an oil sample analysis with dissolved gas analysis, commonly referred to as DGA. This involves drawing an oil sample from the transformer and sending it to a laboratory for analysis. DGA can detect the presence of dissolved gases in the oil, which are often indicators of incipient faults or insulation aging. Specific gases and their concentrations can help pinpoint the type and severity of the problem. Fifthly, perform an insulation resistance test, often called an IR test or a Megger test. This test measures the resistance between the transformer windings and ground. The IR test assesses the condition of the insulation and the absence of moisture or contamination. A low insulation resistance reading suggests potential insulation breakdown. Sixthly, conduct an excitation current test. This test measures the amount of current required to excite the transformer's magnetic core. The excitation current test provides insights into the transformer's magnetic characteristics and core losses. Abnormal excitation current can indicate core lamination issues or other core-related problems. Seventhly, perform load loss and no load loss tests. These tests measure the power losses within the transformer under different loading conditions. Load loss tests assess the losses that occur when the transformer is carrying its rated load, while no load loss tests measure the losses that occur when the transformer is energized but not supplying any load. These tests verify the efficiency and thermal performance of the transformer. In addition to these core tests, consider the following additional points. Consider using a third-party testing laboratory to perform these tests for impartiality. An independent laboratory can provide unbiased results and ensure that the tests are conducted to industry standards. Ensure the tests are performed in accordance with relevant industry standards such as Institute of Electrical and Electronics Engineers, often referred to as IEE, or International Electrotechnical Commission, often called IAC. These standards provide detailed guidelines for conducting transformer acceptance tests. Keep detailed records of all test results for future reference. These records can be valuable for tracking the transformer's performance over time and identifying any potential problems early on. Let's delve into each of these tests with more detail. When performing the visual inspection, check for things such as the paint and whether it has been damaged during shipping, as well as any dents on the cooling fins. This is a good time to verify the oil level in the transformer and check for any leaks around the bushings, radiators, or other connections. If the transformer is equipped with pressure relief devices, inspect them for any signs of activation. Also, take pictures and document everything that you find. With transformer turns ratio testing, a specialized instrument called a transformer turns ratio meter, often abbreviated as TTR meter, is used to apply a low voltage signal to one winding and measure the induced voltage on the other winding. The ratio of these voltages is the turns ratio. Compare the measured turns ratio to the nameplate value, and any significant deviation can indicate a problem with the windings. Typical tolerance is usually within 0.5%. When conducting the power factor test, a power factor meter is used to measure the power factor or dissipation factor of the transformer insulation. The test is typically performed at different voltage levels, and the results are compared to previous test data or industry standards. A high power factor value indicates increased insulation losses and potential degradation. For the oil sample analysis with dissolved gas analysis, collect the oil sample in accordance with established procedures to avoid contamination. The sample should be sent to a qualified laboratory that specializes in transformer oil analysis. The lab will perform various tests to determine the concentration of dissolved gases, moisture content, and other important parameters. Different gases indicate different types of faults, such as overheating, partial discharge, or arcing. For example, high levels of hydrogen and methane often indicate overheating, while high levels of acetylene suggest arcing. For the insulation resistance test, use a megometer, also known as a megger, to apply a high voltage direct current voltage between the windings and ground. The insulation resistance is then measured. The test voltage typically ranges from 500 volts direct current to 5000 volts direct current, depending on the transformer's voltage rating. The insulation resistance value should be above a certain threshold, as specified by industry standards. Factors such as temperature and humidity can affect the insulation resistance, so it is important to record these parameters during the test. For the excitation current test, apply rated voltage to one winding of the transformer, typically the low voltage winding, and measure the current flowing into that winding with the other windings open circuited. The excitation current should be within the manufacturer's specified limits. A high excitation current can indicate problems such as shorted turns in the windings or co-lamination faults. For the load loss and no load loss tests, these tests typically require specialized equipment and expertise. No load loss tests are performed by energizing the transformer at rated voltage and frequency with the secondary windings open circuited. The input power is measured, and this represents the no load losses, which are primarily due to core losses. Load loss tests are performed by energizing the transformer and loading it to its rated capacity. The input power and output power are measured, and the difference represents the load losses, which are primarily due to winding losses. These tests can also be used to calculate the transformer's efficiency and impedance. When selecting a third-party testing laboratory, look for a lab that is accredited by a recognized organization. Accreditation ensures that the lab meets certain quality standards and has the necessary expertise and equipment to perform the test accurately. Also, review the lab's experience and reputation in the field of transformer testing. Industry standards such as Institute of Electrical and Electronics Engineers Standard C57, 1290 and International Electrotechnical Commission Standard 60076 provide detailed guidelines for conducting transformer acceptance tests. These standards cover various aspects of testing, including test procedures, equipment requirements, and acceptance criteria. It is important to follow these standards to ensure that the tests are performed correctly and that the results are reliable. When keeping records of test results, include the date of the test equipment used, the test conditions, and the test results. Also include any observations or comments that may be relevant. These records can be used to track the transformer's performance over time and identify any potential problems early on. By performing these acceptance tests and following these additional considerations, you can ensure that your pre-purchased oil-filled pad mount transformer is in good condition upon arrival and will provide reliable service for many years to come. These tests help to identify any potential problems early on, before the transformer is put into service, and can save you time and money in the long run. It is important to note that these tests are not a substitute for a thorough design review and quality control during the manufacturing process. However, they can provide an additional level of assurance that the transformer meets your requirements. Also, consider performing routine maintenance and testing on the transformer throughout its service life to ensure continued reliable operation. This includes periodic oil sampling and analysis, insulation resistance testing, and visual inspections. By following a comprehensive maintenance program, you can extend the life of your transformer and minimize the risk of failures. Safety is paramount when working with transformers. Always follow safe work practices and wear appropriate personal protective equipment when performing any tests or maintenance on transformers. Ensure that the transformer is de-energized and properly grounded before working on it. If you are not familiar with transformer testing and maintenance procedures, it is best to hire a qualified professional to perform the work. These tests are generally performed in the order that they were described. It is important to allow the transformer to stabilize temperature-wise for at least 24 hours prior to testing. The transformer should be placed in its service location so that final connections can be made. Remember to record ambient conditions such as temperature and humidity. Take photos of the transformer, nameplate, and connections. Use properly calibrated test equipment. Always follow the manufacturer's instructions for the test equipment. If any test fails, stop and consult with the manufacturer. You should also verify the qualifications of the testing personnel and ensure that they are properly trained and certified. Finally, consider having witness points during the testing process. Witness points allow you to observe the testing and ask questions. Good communication between the testing personnel and the customer is key to ensuring a successful acceptance test. By following these guidelines, you can ensure that your transformer is properly tested and that it meets your requirements. Now, let's consider some additional factors that may influence the specific acceptance test you choose to perform. The size and voltage rating of the transformer will affect the complexity and cost of the tests. Larger, higher voltage transformers typically require more extensive testing. The criticality of the transformer's application is another important consideration. If the transformer is supplying power to a critical load, such as a hospital or data center, you may want to perform more comprehensive testing to ensure its reliability. The age and condition of the transformer should also be taken into account. If the transformer is new, you may only need to perform basic acceptance tests. However, if the transformer has been in service for several years, you may want to perform more extensive testing to assess its condition. Finally, the cost of the tests should be weighed against the potential benefits. Acceptance tests can be expensive, but they can also save you money in the long run by identifying potential problems early on. Let's talk about each test again in more detail and what specific values you should be looking for. For visual inspection, document any damage, corrosion, or oil leaks. Verify the nameplate information, including the kilovolt amps rating, voltage ratings, impedance, and tap settings. Inspect the bushings for cracks, chips, or other damage. Check the cooling fans, pumps, and other accessories for proper operation. For transformer turns ratio, compare the measured turns ratio to the nameplate value for each tap position. The tolerance is typically within plus or minus 0.5%. Significant deviations can indicate shorted turns or other winding problems. For the power factor test, the power factor should be below a certain threshold as specified by industry standards. Typical values are less than 0.5% for new transformers. High power factor values indicate decreased insulation losses and potential degradation. For the oil sample analysis with dissolved gas analysis, monitor the concentrations of key gases such as hydrogen, methane, ethane, ethylene, acetylene, and carbon monoxide. Compare the results to previous test data or industry standards. Sudden increases in gas concentrations can indicate developing faults. For the insulation resistance test, the insulation resistance should be above a certain threshold as specified by industry standards. Typical values are greater than 1000 megohms for new transformers. Low insulation resistance values indicate potential insulation breakdown. For the excitation current test, compare the measured excitation current to the manufacturer's specified limits. High excitation current values can indicate core lamination faults or other core-related problems. For the load loss and no load loss tests, compare the measured losses to the manufacturer's specified limits. Excessive losses can indicate winding problems, core problems, or other issues. Also, calculate the transformer's efficiency and impedance and compare them to the nameplate values.